We're going to look at some harder Pythagorean identity proofs. Remember, you want to use a Pythagorean identity if you see two terms that are squared or a term with a squared and then a 1 next to it. That's not always the case, but oftentimes if you see that, you want to try that. In the first example, we see a squared and a 1 together in the numerator, so let's try to use one of the Pythagorean identities to substitute something in. Out of these three, the one with a sine squared and a 1 is the top one, so let's write that off to the side. We know that sine squared x plus cosine squared x equals 1. And remember, we are allowed to move terms around from the left and right sides in our side work, just not in our proof. So we need exactly a sine squared x minus 1. The sine squared is positive, so we need to keep this sine squared here. Let's bring the 1 over. So the sine squared x minus 1 needs to be by itself. Let's move the cosine squared over. We'll subtract it from both sides. Now we have something that matches, and we can substitute negative cosine squared x inside instead. Negative cosine squared x instead of everything that we just underlined, because that's what it equals, over sine squared x. Cosine over sine is cotangent, and they're squared, so cotangent squared x, and there was a negative, so negative cotangent squared x. In this example, we don't see two things that are squared on the same side, and we don't see a squared with a 1 also. It's already in terms of sine and cosine, which was our last strategy, changing everything to sines and cosines. So let's try to see if there's any algebra that we can do. There are two terms here that both have a sign. So if you remember some basic factoring, if you have two terms that both have a number, you can factor out the 2 and then write down what's left. Similarly here, both terms have a sine x, and I think it helps to underline the terms that you're looking at. Remember, terms are separated by pluses and minuses, so that helps us to see which terms are which. They both have a sine x, so we can factor that out. We're left with the cosine squared x in the first term and a 1 in the second term. Now we see a squared and a 1, so let's try Pythagorean identity. We want to look for one of them that has a cosine squared and a 1, which is the first one again. So off to the side, we know that sine squared x plus cosine squared x equals 1, and we want to manipulate it to look like what we have in the problem. So we need a positive cosine squared, so I'm going to leave that here, and a minus 1, let's bring that over. But remember, it needs to be by itself, so let's bring the sine squared over. We'll subtract that from both sides. Now we have something that matches, so we can substitute the other side in for what we underlined in the problem. So we have sine x times, instead of all of that, we have negative sine squared x. Let's peek back at our end goal. We need it to be negative sine cubed x. Well, if we multiply these together, that's what we're going to get.